Hi there, welcome to Mini Math Lessons with Karen, and today we are looking at a lesson that involves matrices and using matrices to help you find the number of possible routes or in a net. So in this case, it's a map between towns and how many different routes can you get from one town to another. If you only want to go there directly, if you want to pass through another town, if you want to pass through two other towns, those types of things. So I'm using Classpad.net, and just a reminder, this is the landing page, and it has, if you've never been here before, it has a lot of options up here to support you. This kind of explains overall, and this is also a video that explains. We have trainings. More importantly, we have a video, which is a great resource, YouTube channel that has lots of how-tos on it. And then we have free activities that you can link to here. And there is a quick link to the user guide. So if you just want to find something out really quick, user guide's great. And that's also within the, once you log in as well, you get that, and the function list. So if you don't have an account, it's okay. You can just play with the activity. All you need is the URL, which I have provided in the description of the video. And if you want to create an account, it's easy to do. Just click this button here, and it's a free account, and you can then save anything you do. If you don't have an account, you can work and have fun, but you're not going to be able to save your work. So creating an account is important to save anything that you want to do or to create something from scratch once you kind of start exploring. So create an account at some point is something I suggest, because then you can save everything that you do and create some new things. So I'm going to just click right into the activity right now and sort of work through it. So this is an activity where we have this girl that's going to Clemson University. She lives in Simpsonville and she has to drive there, and apparently there is a lot of construction, so she's trying to find alternate ways to get here. So this map is basically a net where each node is a town. And the idea is how many options, how many ways can you get from her town she lives in to Clemson? How many different ways? So the initial determination matrix is the initial possibilities to get to one town. So from Simpsonville, she can get to Malden, but she'd have to go through another town to get to Greenville, so she can't get directly to Greenville. And if you look right now, she can't get directly to Clemson either. She always has to go through at least one town. So that's sort of what we're determining, is if she only wants to go through one town, how many options does she have? If she wants to go through two towns, how many options? If she doesn't want to have to go through any towns, does she have any options? And so what you're doing is basically creating a matrix where you're using your nodes. So we have 7 nodes as both the columns. So if you look over here, I have a table. The columns are the 7 towns, and then the rows are also the 7 towns. So we kind of think of times tables. You're reading it like a times table, but this is a matrix. So if I'm in Greenville, so here we are in Greenville, and I want to know, can I get directly, so this is our determination matrix, which is the one path. Can I get directly to the other towns? I am going to use a number system. 0 means no, I can't get directly there. There's another town in between at least. 1 means yes, I can. So if I read across the rows, if I want to go from Greenville to Malden, it means, well, it has a 1, which means yes, I can do it. So if we look on the map, Greenville to Malden, yes, I can get there directly. There's nothing in between. But if I want to go from Greenville to Simpsonville, notice as I read across the row and go to the column Simpsonville, there's a 0 here. That means I can't get there directly because there is another town in between. Either going through Malden or going through Piedmont, I can't get to Simpsonville directly. So that's what these numbers represent in our determination matrix. This is our initial matrix. So what students are then going to do is take this table and actually put it into a matrix, so that they can then calculate with it, because you can't calculate matrices with the table. So we're just going to convert this table to an actual matrix. And we're using this colon equal because we're going to define the matrix to be this initial determination matrix, and then we can use it over and over again without having to re-enter all the numbers. So to enter them, we're just going to basically follow the table up here. So I've got 0, 1, 1, 0, and I'm not going to sit here and enter these and waste our time. So I'm going to actually pause the video right now, and I'll come back when it's all right, welcome back. That was quick. So here's my matrix. I entered all of these. It matches the table. So again, the columns are the towns and the rows are the town. And the ones represent if I have a direct path from one town to another. And so when I hit enter, so I enter the matrix, and when I hit enter, because of this colon equals, it just creates a version of the same matrix. Because basically all I've done is told the computer, the calculator, that this is the matrix A that I want you to use all the time, and it is confirming that now this is the matrix A. But now I can use that matrix in other operations by just naming it A, and I don't have to re-enter all of these values that are in it. So that brings us down. So students are going to answer questions about this initial matrix, and they can use the table or the map to kind of confirm. So lots of representations there. And then we're going to expand that. So we know this one represents if you can get from one town directly to another. But if we then say, okay, what if she wants to go somewhere, say she's going to Clemson, how many options does she have if she wants to only go through one town, right? So if she only wants to go through one town, so that is basically the next level of matrix A. So power, so square. So we're going to square it. So remember, because I don't have to enter the matrix again, I defined it to be A all the time. All I have to do now is just do the operation. So I'm going to square matrix A. And what that's going to do is give me a second matrix, and we might want to just expand so we can see it. And notice it is different than the initial one because we squared it, right? And now, so what do these numbers represent? Well, this is our matrix where we're looking at how many possible routes are there for her to go from a town through just one other town. So how do we read this? So let's say she lives in, let's go back up to our table. She lives in Simpsonville, which is the fourth column, and she wants to get to Clemson. So we're going to go 1, 2, 3, 4, and go down to Clemson. And there's a 2 there. Well, that means there are 2 possible routes from her town she lives in to go through one other town to get to Clemson. And so these numbers represent the possible routes that she could take. So if I'm in 1, 2, 3, 4, I'm in Simpsonville, and remember the first row is, the second row is, let's look, Malden. So here's her town, the column in Malden, there's a 0 here. This means there's no way for her to get to Malden and go through one other town. So what does that look like on the map? Well, if she's in Simpsonville and she wants to go to Malden, and I'm trying to go through another town before I get there, it's impossible for her to do. She can't get it. She can't do it. There's not just one other town she go to. So that's what the 0 represents. So they're going to answer some questions based on this, and then they're going to do it again. They're going to say, okay, well, this time we want to go through 2 other towns. So how many possibilities? So you're going to take that initial A matrix again and just cube root it, right? So we could keep doing this and figure out how many different routes they are. So we're using matrices to determine the routes, and then we can use the other representations to help us specifically find the routes. So we just figured out that there are 2 possible ways for her to get from her town, Simpsonville, to Clemson, going through one or other town. And so let's look. So we know we're looking for 2 routes. So here's Simpsonville. And here's one town, we get to Clemson. So there's one route. And then here's Simpsonville, here's another town, and then Clemson. So these are the 2 routes, Simpsonville to Peltzer to Clemson or Simpsonville to Piedmont to Clemson. All the rest are more than one town, right? So that's what we're doing. And students will be exploring that and kind of basically looking at the different representations to figure out routes, how many there are, and then what are those routes. So have fun exploring that.